You've now defined an important process improvement problem. You've collected data, measured and analyzed the data to determine all important variables and facets, and you have developed a strategy for improvement. Now it's time for the implementation. The objective of the control phase is to implement the solution, ensure that this solution is sustained, and share the lessons learned from the improvement projects throughout the organization. With this approach, the projects start to create excellent returns. Thus, the best practices in one part of the organization are translated quickly to result in implementation in projects carried out by another part of the organization. Let's discuss some important tools you can leverage during the control phase. A Gantt chart is useful in project management as it provides a dictation of the start and finish times of each activity within a project. The tool represents time as a bar or a line on a chart. These start and finish times for activities are displayed by the length of the bar, and often the actual progress of the task is also indicated. There are 6 basic steps in the creation of a Gantt chart. Identify the key activities or the tasks related to the project and describe each activity by selective keywords. Prepare a scheduling board, and depending on the duration of the project, draw vertical lines to divide the board into monthly, weekly, or daily intervals. Arrange the activities in a sequence of estimated start dates and post them on the extreme left-hand column of the board. Estimate the start and finish dates of each activity and draw horizontal bars or lines along the timescale to reflect the start and duration of each of the activities. On completion of each activity, show the actual start and duration of the activity by a bar of a different color. Include a Time Now marker on the chart. Review and maintain the chart until the end of the project. Later on in this unit, you will watch a video on how to enact a simple Gantt chart through the use of Excel. This is a very useful tool in the control phase as it sets up a schedule for continuous improvement going forward. Let's now discuss the activity network diagram. This is a representation of a brief description of all tasks, their sequence, their expected completion time, and the jobs that can be carried out at the same time, also referred to as a parallel process. There are 7 basic steps in the development of an activity network diagram. Assemble the project team with the ownership and knowledge of key tasks. List the key tasks with a brief description for each one. Identify the first task that must be done, the tasks that can be done in parallel, and the sequential relationship between tasks. Draw arrows for each task, which are labeled between numbered nodes, and estimate a realistic time for the completion of each of these tasks. Avoid feedback loops in the diagram. Unlike Gantt charts, the length of the arrows does not have any significance. Determine the longest cumulative path as the critical path of the project. Review the activity network diagram and adjust resources and schedules if appropriate. During this unit, you will learn how to devise an activity network diagram using the example of writing and submitting a manuscript to a journal. The key here is to determine the critical path, which is the longest sequence of dependent tasks in a project. It's a key concept in project management, helping to identify the tasks that directly impact the project's overall duration. If any task on the critical path is delayed, the entire project will be delayed. Additionally, using a network diagram to show project dependencies will help you figure out which tasks can and can't be done simultaneously so that you can plan your schedule accordingly. A radar chart, also known as a spider chart or polar chart, is a 2-dimensional data visualization tool used to display multiple quantitative variables for comparison. Data points are plotted on a radial grid with aces and connected to form a polygon, allowing for easy comparison across different categories or groups across various metrics. There are 6 basic steps in creating a radar chart. Select and define the performance categories. Typically, the chart can handle 10 to 20 categories. Some performance metrics are likely to be easily quantifiable and expressed as a percentage. Other metrics may be qualitative and not represented by numbers. Select what's most appropriate for your objectives. Normalize all performance metrics in a scale with appropriate guidelines. For example, a Likert scale ranging from poor to excellent, where 1 is poor and 5 is excellent. Construct the chart by drawing a wheel with as many spokes as the performance categories and marking each spoke with 0 at the center and 5 on the rim, or whatever number suits your scale chosen in the previous step. Connect the ratings for each performance category and highlight the gaps. Use the results for consolidating strengths and improving weaknesses. The following is an example of a radar chart for 3 products, Product 1, 2, and 3. and how each were rated on 6 dimensions: price, usability, quality, appearance, advertising, and durability. As you can see, Product 3 was rated the highest on price and appearance, whereas Product 1 was rated highest on advertising and Product 2 on usability. The PDCA cycle, also known as the Deming cycle or Shewhart cycle, is a 4-step iterative method for continuous improvement of processes, products, or services. It stands for Plan, Do, Check, and Act. The cycle is a continuous loop, meaning that once the act phase is complete, the cycle starts over, allowing for ongoing refinement and improvement. There are 4 basic steps in the PDCA cycle, with a 5th stage added based on results. P. Plan. Stage. The cycle starts with the plan stage, comprising the formulation of a plan of action based on the analysis of the collected data. D. Do stage. The next step is the do or implementation stage. This may involve a mini PDCA cycle until the issues of implementation are resolved. C. Check stage. The next step is the check stage, where the results after implementation are compared with targets to assess if the expected performance improvement has been achieved. A. Act stage. At the final act stage, if the change has been successful, then the outcome is consolidated or standardized. If the change has not been successful, however, the lessons are recorded and the cycle starts again. Even if the change is successful, the results are sustained by going through the PDCA cycle over and over again. The PDCA cycle is more than just a tool. It is a concept of continuous improvement processes embedded in the organization's culture. The most important aspect of PDCA lies in the act stage, after the completion of a project, when the cycle starts again for further improvement. A milestone tracker diagram, also known as a milestone chart, is a visual representation of a project's key events or milestones placed along a timeline. It provides a high-level overview of project progress, focusing on significant accomplishments and deliverables rather than detailed task lists. This allows for a quick understanding of where a project stands and what needs to be achieved to reach the next stage. There are 7 basic steps for developing a milestone tracker diagram. Determine the key events of the project as milestones. Establish the planned delivery dates of the milestones and agree to the dates with the project manager and sponsor. Draw 2 axes at right angles to each other and mark these axes in a suitable scale of weeks or months. The total period should allow the milestones to extend under the worst possible conditions. Choose the x-axis as the estimated finish week of milestones and y-axis as the week of progress review. The axes should be of equal value. Note that the y-axis is in the reverse direction as compared to a conventional graph. Draw a diagonal line from the top of the y-axis, 0, to the maximum duration point on the x-axis. During every week of progress review, plot the estimated delivery dates of each milestone. At any time during these progress reviews, the project manager can draw the best fit straight line to connect these revised estimates. If these straight lines are projected, they will intersect the diagonal line at points which can be taken as the predicted delivery dates of milestones. The following example is of a milestone tracker diagram where the progress of 2 milestones has been illustrated. The planned finish dates of Milestone 1 and Milestone 2 are Week 4 and Week 8, respectively. According to this tracker, Milestone 1 is on track while Milestone 2 has experienced some delays, and thus its predicted finish date is Week 9 instead of Week 8. EVM, or Earned Value Management, is a project control tool for comparing the achieved value of work in progress against the project schedule and budget. It can be performed at the single activity level and by aggregating the results up through the hierarchy or work breakdown structure. Earned Value Management, or EVM, is basically a bilingual translator that tells you how cost and schedule are really getting along, but it works best when the project already speaks the tidy language of work breakdown structures like you find in engineering jobs. At each Time Now checkpoint, it can flash red or green lights, showing today's cost and schedule variances, projecting the final price tag and finish line, and flagging which parts of the work are dragging efficiency down, but it's still just an early warning siren, not the fire brigade. If your progress measurements are fuzzy, if the clerical backend isn't maintained, or if big chunks of the budget sit in lump sum purchases, the numbers wobble. Add in the fact that EVM ignores risk and uncertainty entirely, and you can see why blind faith in its charts is risky. Bottom line, use EVM as a radar screen to spot trouble early, then combine its signals with solid risk management and a team that actually understands what those curves mean. In this unit, we will go through an example of EVM step by step. Although this may not be needed for your project in this particular class, it is useful to know in the long term for possible new process improvement projects you may run into going forward. Operational excellence isn't a sprint, a flavor of the month, or a banner on the wall. It's a discipline. Document, share, sustain, and control is the chapter that never ends. As you head to your capstone projects, ask yourself, what will stop my gains from evaporating next semester? The answer lives in the tools we just explored. Thanks for watching. Remember, in the world of improvement, there's no finish line, just the next define. When you hit control, the clock resets, the data whispers new questions, and the DMAIC wheel rolls on. So celebrate the gains, but keep your running shoes laced.